Okay, so last night we talked about a bit about quadratics and the standard form, which we have here. And we learned yesterday a little bit about what happens with this standard form. We learned hopefully that c is the y-intercept, and that its shape and size change on base A and B, and also that A dictates whether it's pointing up or down. And we also talked just a little bit about the axis of symmetry, which is the line that cuts the parabola down into two equal parts. And there's a formula for the axis of symmetry. It's negative b over 2a, because we don't always have a graph, especially if you're in an inactive part of the test. You may be given an equation, and you have to find the axis of symmetry based on the equation. So we're going to look at an example here, such as this one. We need to find out what the axis of symmetry is. So I want to think about my equation. It was negative b over 2a. And if we remember, our a is here, our b is here, and our c is here. That didn't turn out very good. Okay. I don't see a number here for a, so I know it must be 1. Okay. So I'm trying the axis of symmetry. I'm going to plug in my 5 for my b and my 1 in for a. So I'm going to have negative 5 over 2 times a, which is 1. So I'm going to have negative 5 over 2. So my axis of symmetry is at x equals negative 5 over 2, or we could say negative 2.5. Okay. So I know if I, wherever this parabola is, it's going to have a vertical line at the 2.5. Okay. And looking at another example here. Here we have another standard form equation. I know it's going to cross the y-axis at 7. That's the y-intercept. And then I also know that this is my A, my B, and my C. So if I'm trying to find the axis of symmetry, again, I want to use the negative b over 2a formula. So I'm going to plug in, now my b here is negative 8. So this is going to be negative 8, because negative 8 is my b, and my equation has the negative in it. And then I'll have that over 2, and then I'll replace a with 3. So now I'm going to have negative 8, which would give me a positive 8. And then I have 2 times 3, which is 6. I can reduce this down to, let's see, 4 goes in, or 2 goes in there. 4 times over 3. So I can say my axis of symmetry is a vertical line at x equals 4/3. Or we could say 1 1/3, but we would not put this into a decimal, because 1 1/3 is 1.3 repeating, and then we would have to round, which would give us an approximate answer, not an actual answer. Okay. And then another thing, just looking at this, I know that my y-intercept is at 7. Now I can also figure out what the vertex is given finding the axis of symmetry, because I know if this is my parabola, I know my axis of symmetry goes right down the middle. So I know that the x has to be 4/3. And then I would just have to find my y, and that would give me the vertex of this equation. Or we could also call it the minimum value. So in order to do that, if I have my x, I've got to find my y, and very simply the way to do that would be just to plug it in. So I would take this equation here, and I would have my 3, and then I know x is 4/3. So I would do 3, and then I would have 4/3 squared. And remember, f of x is also the same thing as y equals, so we can put a y equals here. And then I have negative 8 for x. I'm going to put in 4/3. And then we have plus 7. Okay, so then I need to do a little simplifying there. So I have 3, and then I square both of these. So this becomes 4 squared, which is 16, and 3 squared, which is 9. And then minus, and then when we do 8 times 4 thirds, I do 8 times 4, which is 32 over 3 plus 7. So now I need to multiply this. 3 times 16, that would give me 18, carry the 1, 48 over 9 minus 32 over 3 plus 7. Still trying to find out what that y value is for the vertex. So I would need to make these like terms here because we're subtracting. So if I times the top and bottom by 3, this will give me a 9 on the bottom, and let's see, 96 on top. So then I'll have 48 minus 96. So yeah, 48 minus 96, which will give me 48 minus 96 is negative 48, sorry, over 9 plus 7. That looks terrible, sorry. This is negative 48. And that's a 9. Okay, so this is a little bit easier if I have it in mixed form. So I know 9 goes into 48 a negative 5 times, and then we have, because that's 45, and then we have 3/9 or 1/3 left over, and then plus 7. So then I just have to figure out what negative 5 and 1/3 plus 7 is. I know this is really messy. So that'll give me negative 1 2/3. That was a long, tedious way to figure out the vertex is at when x is 4 over 3, and then look at this. That would be negative 3 plus 2, if I want to make this improper, right? Negative 3 plus 2, which would give you negative 5/3, right? I think so, right? 3 times 1 is 3, plus 2 is 5. So this would be my vertex. I hope we don't have to do too many of those. That was really messy. Okay, so we can use the symmetry equation to find the line of symmetry, which is your vertical line at x equals. Once we have that x, we can plug it in and find the y, which will give me the vertex. So last thing I want you to do is I want you to use the axis of symmetry equation and find the axis of symmetry of number 3 here. So come in with that answer for me, and we'll go over it tomorrow. Have a great night.